A very warm welcome to all. To commemorate India's 75th year of independence and encourage young minds to choose science and technology as a career option, the Regional Center for Biotechnology is organizing a webinar series as a part of DBT Science Setu program. Today's webinar is prepared by our young and bright MSc students, that is Harsh, Sahil, Diksha, and Bharti. They will showcase the life and works of eminent scientist Dr. Ramalingaswami. In addition, we will like to present a virtual tour of RCP campus and its facility, followed by a question and answer session with Dr. Prashant Pawar, who is assistant professor at RCP. Now, without further ado, let's invite our team for the presentation. Harsh, please join in.
Thank you, Dr. Nidhi, for a nice introduction. In today's webinar, we will be highlighting the life and scientific journey of Dr. V. Ramalingaswami. He was a physician and a scientist in nutritional biology who made some key contributions in the life of common people. In addition, his contribution in several health issues is well known. We, the student of RCB, would like to take you to the journey of Dr. V. Ramalingaswami. We hope that you enjoy it.
Dr. Vullimiri Ramalingaswami was born on 8th of August 1921. He was a well-known Indian medical research scientist for nutrition and pathology. Ramalingaswami was undoubtedly the most outstanding, multifaceted medical personality of independent India. Dr. Ramalingaswami left for his heavenly abode on 28th of May 2001. Dr. Ramalingaswami was born on 8 August 1921 in Srikakulam in Andhra Pradesh, India. He was known to his friends and family as Rama. He was named after his grandfather, who was also named Vullimiri Ramalingaswami. He grew up within a joint family among 20 to 25 children, 8 of which were his contemporaries. As a child, the single greatest influence on Rama was that of his paternal grandfather, Vullimiri Ramalingaswami. He was a scholar of Sanskrit, Telugu, and English, and he was a graduate in English literature from Madras University. He carried the honorific title of Pantulu Garu, which in Telugu means respected teacher. Rama's grandfather was a true nationalist who did not want to serve under the British government and therefore chose to be headmaster of a high school started by a local in the small town of Bobili, which he later developed into the best school in the Andhra Pradesh at that time. Rama acquired his personality traits from his parents and grandparents. From his grandfather, he acquired his strong nationalist streak, a respect for high-quality education and modesty. From his father, V. Gumpaswamy, he acquired the ability to see only the good in everyone, and from his mother, Sundarama, he acquired the ability to arrive at a consensus from very many differing views. As a child, Rama was rated as the best student of his times and was equally at ease as an artist and a sportsman. Music was another abiding interest that he acquired from his grandfather. He used to play Sanskrit pieces on the complex Indian musical instrument, the veena, and joined the other children in music practice by singing. While growing up, the greatest concern of Rama's grandfather was choosing a suitable girl for Rama to marry. He needed a girl who understood the consequences of being the wife of a researcher. In 1947, at the age of 26 years, Rama married the rather young Prabha, then 16 years old and in the last year of high school. It was an arranged marriage. Prabha was already known to Rama's family. She was not only intelligent and academically bright, but she also excelled at extracurricular activities. Moreover, she was herself greatly fascinated with science and research. Rama ensured that Prabha would continue with her education. He encouraged her to continue with the BA degree from Andhra University. Later, Prabha also did an MA degree from Aligarh Muslim University and a PhD in psychology from Andhra University. She later became a professor at the Jawaharlal Nehru University in New Delhi. Moving on to Rama's career and education. Rama graduated from the Andhra Medical College in Visakhapatnam in 1944. 2 years later, he obtained an MD in internal medicine from the same college. This was quite unique in those days. Rama was a true physician in that all of his actions were aimed at an understanding of human disease and the prevention of human suffering. Rama began his career in nutritional research, which enabled him to achieve unparalleled heights as the foremost biomedical scientist of the country of his time. His contributions are significant in the areas of protein energy malnutrition, iodine deficiency disorders, nutritional anemia, and liver diseases in the tropics. Now let us have a look at Rama's diverse academic journey. As mentioned before, Rama completed his MBBS and MD from Andhra Medical College, Visakhapatnam in 1946. After completing his medical studies from Andhra University, Rama and his grandfather discussed the various options he could pursue in the future. Right from his college days, Rama was passionately interested in science and research. His grandfather believed that research would provide him the academic satisfaction that he craved for, although not the monetary gains that other career options would provide. Instead of opting for a well-paid career in medical practice, Rama joined the Nutrition Research Laboratory located in Kunur, now known as the National Institute of Nutrition in Hyderabad, where he developed a long-lasting interest in the nutritional problems of the Third World. Generally, medical scientists tend to focus on narrow areas of research, be it pure laboratory studies or discipline-oriented clinical work. Rama initiated a shift in the standard pattern by focusing on the complete chain, right from laboratory research to the concerns of clinicians and the health needs of the community. It was at the NRL where Rama published his first paper titled Hepatic Cholesterol Content in Nutritional Disorders. It was published in The Lancet in 1952. A few years after joining the NRL, Rama went to the Oxford University, where he obtained his doctorate in philosophy in pathology in 1951. Specifically, his research with Dr. Hugh M. Sinclair was based on nutritional aspects of dermatology. His grandfather was extremely happy when Rama went to the Oxford University as a government scholar. At Oxford, Rama began working on vitamin A deficiency and continued this work when he returned to India. He, along with Sir John Wilson, also initiated programs for the control of blindness, both at the national and international levels. In his work, he showed that administration of vitamin A was important for the prevention of eye problems in children. After completing his tenure in Oxford, Rama returned to the NRL in Kunur as a research officer and resumed his work on a wide range of nutritional pathologies. He published several papers in Indian medical journals on a wide range of nutritional conditions, including kwashiorkor, toxic liver injury, and goiter. His research was not discipline bound and brought together community health, clinical pathology, epidemiology, and several other observational studies and combined these to successful problem solving strategies. The Nutritional Research Laboratory functioned under the Indian Research Fund Association, or the IRFA. Rama joined Dr. C.G. Pandit in expanding the role of IRFA in promoting research in medical colleges, thereby converting the Indian Research Fund Association into a new agency, the Indian Council of Medical Research, or ICMR. Rama joined Dr. Pandit in this mission and served as the Assistant Secretary and later as Deputy Director from 1954 to 1957. During this period, Rama also assisted him in formulating plans for the health sector in the National Second Five-Year Plan. In the 1940s, the Government of India set up the Bhor Committee to solve the health problems of the Indian people. After independence, the Parliament established the All India Institute of Medical Sciences, well known as the AIIMS, in New Delhi, based on the recommendations of the Bhor Committee. Rama applied for the job of an associate professor in the AIIMS, but was selected for being the founder professor and head of the Department of Pathology. Within a span of 10 years, he established a leading school in pathology which attracted the best talent from across the nation. Rama revolutionized the teaching of pathology by bringing in the best practices from several advanced research centers from across the globe. Unlike the norm prevalent in other medical colleges, he encouraged his graduate students to take up challenging research projects. An aura of novelty and excitement was perpetual even in the early days of his laboratories, even though the labs were not very well equipped during their initial days. Rama spent 2 decades at the AIIMS, first as the professor and head of Department of Pathology from 1957 to 1969, and later as the director of the institute and professor of pathology from 1969 to 1979. Rama made the most significant contributions of his career during these 2 decades at the AIIMS. A year later, Dr. H.D. Tandon, one of Rama's colleagues, also went on to become the director of the AIIMS from 1980 to 1984.
Soon after becoming the director of AIIMS, Rama magnified the glory of the institute by his unparalleled contributions in diverse research programs, including nutritional pathology and protein energy malnutrition, thyroid goiter and iodine deficiency disorders, nutritional anemia, liver disease, and cardiovascular diseases. Rama was always inclined towards finding the solution rather than merely giving the description of the pathology. This holistic approach was the reason why his work was so applicable in combating various health problems. Rama's work on kwashiorkor led to the development of the first non-human primate model of kwashiorkor, which was further used to study the effects of protein energy malnutrition virtually on every organ of the body. These studies led to the discovery of protein deficiency being the major cause of manifestation of protein energy malnutrition, which was earlier thought to be caused by calorie deficiency. It was observed that these defects could be reversed by timely correcting the nutritional deficiency. To study the cause of endemic goiter, which was widely prevalent, Rama and his colleagues conducted a detailed community-based study involving more than 1 lakh people. This experiment, well known as the Kangra Valley experiment, confirmed that a very small dose of iodine could prevent endemic goiter. It was recorded by Dr. Rama as shown above. India was struck by widespread anemia, especially among young women. Anemia in pregnant women is a common cause of infant mortality. Considering the same, Rama initiated extensive epidemiological study. His study, titled Geographic Pathology of Iron Deficiency with Special Reference to India, was published in the American Journal of Clinical Nutrition. In this study, it was found that iron deficiency and to a small extent folate deficiency was the most important cause of anemia in pregnant women. Therefore, successful iron and folate supplementation in the prenatal period and in childhood is believed to be the single most important measure for improvement of the health of women and children worldwide. Rama's significant contribution in the field of nutritional anemia had an unprecedented impact, which led to the formulation of National Nutritional Anemia Control Program by the Government of India. The group extended its studies outside India in collaboration with colleagues in Sri Lanka and South Africa. Their study was incorporated in WHO Technical Review Series and publications of the International Nutritional Anemia Consultative Group. In 1955 to 56, there was a large epidemic of jaundice believed to be due to hepatitis A virus. Rama, along with Dr. Nayak, made extensive studies on viral hepatitis during that period. Using more sensitive diagnostic tests, it was found that jaundice was not due to hepatitis A virus, but due to a non-A, non-B waterborne virus, shown to be hepatitis E virus by Dr. Nayak and his colleagues. He made several other contributions in liver diseases. He described the entity of non-cirrhotic portal fibrosis. He disapproved the myth of nutritional cirrhosis, establishing its viral etiology. He extended the studies on toxic liver injury and Indian childhood cirrhosis. He elaborated the pathology of liver changes in kwashiorkor in the subhuman primate model. Rama contributed in the field of cardiovascular diseases as well. He, along with his clinical colleagues, described entity of juvenile mitral stenosis in India. During the Bihar famine of 1967, he revealed that degeneration of the myocardium was because of the low blood pressure observed in undernourished people. Rama also conducted detailed investigations on the evolution of atherosclerosis in pigs and the effect of dietary protein and fat on these lesions. In his study, it was found that pigs that were fed on a low protein and high cholesterol diet developed extensive and severe atherosclerosis of the aorta and coronary arteries.
Rama worked at AIIMS for 2 decades and then went to ICMR and became its Director General in 1979. He made several changes to strengthen ICMR by introducing new projects and programs during his tenure. As the Director General of ICMR, Rama achieved a quantum jump in the 5-year plan budget from Rs 13 crores to nearly Rs 150 crores, which permitted him to implement his vision. His vision included creating regional research centers, making the existing ones better, establish centers for excellence, attract young medical graduates to research career, and setting up multi-centric national mental health research initiative. Rama played a vital role in societal health problems such as the plague outbreak which occurred in 1994, child malnutrition, and the Bhopal gas tragedy in 1984. India was struck by two outbreaks, one bubonic plague and another a pneumonic plague in 1994. Government of India set up a technical advisory committee under Rama's chairmanship. During this time, his intellectual and organizational leadership were visible in the detailed report of the committee. Upon discovery of HIV/AIDS, Rama realized that this deadly virus can spread in the country very rapidly. To control the situation, he took various steps which includes establishing testing centers, participating in conferences, becoming part of Board of International AIDS Vaccine Initiative, supporting the development of appropriate AIDS vaccines and testing kits. Child malnutrition is one of the biggest problems which many developing nations including India are facing. In 1996, Rama wrote an article entitled The Asian Enigma, which highlighted the child malnutrition problem associated with low status of women as they suffered with iron deficiency and anemia. He was one of the powerful advocates of women empowerment who took a stand for higher status of women in India. Rama investigated several hunger-affected districts such as famine-affected districts in Bihar and Orissa to fight hunger and malnourishment. He reported his analysis in a report article entitled The Anatomy of Hunger in an international conference. Bhopal gas tragedy occurred in 1984, which shocked the whole nation. Leakage of methyl isocyanate gas from pesticide industrial plant caused death of many people. Rama immediately visited Bhopal and planned the measures which needed to be taken. He mobilized resources, arranged a large number of experts, and brought together medical resources. His journey was really inspiring, which started from being MBBS and MD at Andhra Medical College and becoming part of NRL, Oxford, AIMS, ICMR, and WHO's Global Advisory Committee. Our country lost such an inspiring person on May 28, 2001, but his contribution would not be forgotten for centuries to come.
Ramalingaswami was a prominent scientist who worked in the field of nutrition, and his research was interdisciplinary, which encircled around the life of common people. In addition, he had excellent leadership qualities and made many leaders out of his own students. He was outstanding in any field and encouraged many of his students who ended up rising to great heights, leading completely new areas. Dr. Ramalingaswami was actively involved in several committees and was one of the founding members of some of them. He was an integral part of several organizations across the globe. He was one of the founder fellows of National Academy of Medical Sciences established in 1961. Apart from this, he was a fellow at various national and international institutes such as Royal College of Physicians, located in London in 1969, American College of Physicians in 1970, Indian National Science Academy in 1971. He was a foreign associate of National Academy of Sciences USA in 1973. He was a fellow at Indian Academy of Science in 1974, a member of Royal College of Pathologists London in 1978 and Royal Society of London in 1986. He was a foreign member of the USSR Academy of Medical Sciences in 1984, now known as Russian Academy of Medical Science. He served as the president of Indian National Science Academy from 1979 to 1980. Rama was an affiliate of the Pathological Society of the Great Britain and Ireland, a member of the International Academy of Pathology USA, an associate at the Indian Society of Pathologists and Microbiologists, and he was the president of the Indian Association of the Advancement for Medical Education in 1974. He was honored with various awards for his extraordinary contribution in the field of research and the impact it had on the society. In 1954, he was awarded first Khanolkar Prize by Indian Association of Pathologists for his work in pathology. He was honored with Vatumal Award in 1962. Shanti Swarup Bhatnagar Award in 1965, which is one of the highest honors given for the contribution of science. He was honored with Basanti Devi Amirchand Prize in 1966 by ICMR. In 1974, Medical Council of India awarded the Silver Jubilee Research Award to him. World Health Organization awarded him the Leon Barnard Foundation Award in 1976. In 1977, INSA awarded him the Jagdish Chandra Bose Medal, and the first R.D. Birla National Award for Medical Research was awarded to him in 1980. In 1993 to 94, ICMR honored him with the Dr. B.R. Ambedkar Centenary Award. In 1999, the Indian Science Congress awarded him with the Shatabdi Puraskar. He was awarded with two of the highest civilian awards of the country, the Padma Shri and the Padma Bhushan, by the Government of India. Rama worked on his international commitments to tackle a wide range of issues in the field of nutrition, which had a relevance for developing countries all over the world. In 1955, Rama was sent to Thailand by WHO's Regional Office for Southeast Asia to study the nutrition conditions of Thai people. Rama, along with Dr. Fred Robbins, proposed a collaboration between institutes of India and the USA for the development of vaccines and diagnostics. Rama's coherent nature led to build-up of close relations and friendships with esteemed and distinguished scientists all over the world. Rama was not the one to sit in comfortable air-conditioned offices or laboratories. He went out to study for himself the stark realities that great number of people faced in the wake of great cataclysm of nature or of man-made disasters. Ramalingaswami Bhavan at ICMR has been named after him. In addition, Department of Biotechnology, Government of India initiated Ramalingaswami Re-Entry Fellowship for promoting Indian researchers pursuing science in foreign countries to begin their scientific journey in India, thereby boosting science in our country.
I hope you all enjoyed and admired the journey of Dr. Ramalingaswami. Now, let's take a quick tour of RCB campus and its facilities. And you're welcome to ask any queries regarding RCB program. But just you have to type in your questions in the comments box. Please play the video. Thank you.
Regional Center for Biotechnology is located in a tranquil environment along the Gurugram Faridabad Expressway. It is an autonomous institute established under auspices of UNESCO by the Department of Biotechnology, Government of India. The primary focus of RCB is to provide world-class education, training to create high-quality human resource in biotechnology and conduct innovative research at the interface of multiple disciplines. The infrastructure at RCB has developed at a rapid pace since inception of the institution in 2010, with state-of-the-art research labs, teaching labs, innovative classrooms, central instrumentation facilities, small animal facility, biosafety level 3 facility, a biorepository and state-of-the-art advanced instrumentation facilities like the Advanced Technology Platform Center and a bio-incubator which serves as a reservoir for incubating ideas in the area and help them reach commercialization. There are various areas of research in RCB. The research group under the area titled Cell Biology, Development and Behavior focus on unlocking the secrets of cells, how they divide and how stem cells develop into muscle, in addition to studying the cellular and molecular origins of how organisms behave. Areas of agricultural biotechnology aim to tackle some issues by harnessing the existing genetic diversity in plants and their inherent capacities to adapt to abiotic and biotic stress conditions in order to develop innovative and durable methods of crop improvement. Groups working on infectious diseases, both bacterial and viral, aim at developing novel therapeutic strategies against infectious agents using tools such as mass spectrometry and microscopy. These researchers will shed light on cellular and molecular bases of bacterial infection and the response of the human host towards these infections. They are trying to find novel solutions to protect the people against diseases such as chikungunya virus, Japanese encephalitis virus, and dengue virus. Protein structure and design groups are structural biologists who have a molecular view of life and use cutting-edge methods like macromolecular X-ray crystallography or cryo-electron microscopy to imagine biological molecules in their functional state. This information is used to develop novel therapeutic strategies against pathogenic bacteria and viruses, and for protein engineering to prepare molecules with desired properties. Researchers at RCB are also working towards developing innovative biotechnological applications such as novel drug delivery systems, new diagnostic tools, novel engineered protein with improved desired proteins, and improved methods to obtain desired products in large scale. These researchers subject laboratory and clinical samples to cutting-edge microscopy, proteomics and genomics methods coupled with flow cytometry to shed light on the etiology of disease and utilize this knowledge to identify solutions to these disorders. The quality of research conducted at RCB is excellent, with faculty winning top honors like the Shanti Swaroop Bhatnagar, the National Bioscience, the Innovative Young Biotechnologist Awards, and the Ramalingaswami and DBT Welcome Alliance Fellowships. Since research-based learning is the hallmark of RCB, the academic programs here are deeply enmeshed with the research programs. The academic programs fulfill RCB's core mandate to provide quality education and training in the area of life sciences and biotechnology. The PhD program in biotechnology is for students who are interested in working at the interface of multiple disciplines to find novel solutions for problems in health and agriculture. RCB has recently started integrated PhD program in biotechnology, offered to students with graduate degree in any discipline of science from India and abroad. The program provides extensive learning opportunities in the broad field of life sciences and biotechnology. RCB has also recently initiated an interdisciplinary doctoral programs in the area of biostatistics and bioinformatics through collaboration with the global pharmaceutical giant GlaxoSmithKline (GSK), being conducted in partnership with other institutions by creating a virtual faculty pool. The focus of this program is on creating specialized manpower for the healthcare industry. As an outreach activity, RCB also offers research training programs for research-driven undergraduate and postgraduate students of science from various universities. Trainees get a realistic experience of several facets of modern biological research that sets the tone of their embarking on a research career. Throughout the year, RCB hosts and organizes regular academic events like the RCB Bioimaging School, national and international conferences, seminars, symposia, and training in the frontier area of basic and applied sciences in topics such as infectious diseases, drug discovery, etc., to disseminate advanced knowledge, exchange ideas, foster national and international collaborations, student exchange, and networking opportunities. RCB also holds scientific communication and communication workshops for the benefit of young scientists in India. RCB has a fully functional library and houses 500 scientific textbooks and 100 administrative books in multiple copies. In addition, an electronic library provides access to a vast range of primary literature in the form of peer-reviewed journals and reviews. RCB offers faculty residences and excellent students' facilities, including on-campus air-conditioned hostel accommodation, modern library, meeting rooms, seminar rooms, and auditorium. The hostel and student facilities are conveniently located and only a short walk away from the classrooms and laboratories. In addition, the campus also has sports and recreation facilities which encourages all-round development of the students. Campus also provides a childcare facility for all students and staff to help them continue their studies and work while their babies are being taken care of. Kridangan, the creche housed in the faculty building, is an asset on campus for employees of NCR Biotech Cluster. The spacious cafeteria in the campus serves hygienic, nutritious and delicious meals and beverages at reasonable cost. RCB also contributes towards creating resource for researchers from all over India and has engaged with institutions such as the European Synchrotron Radiation Facility in France towards this end. RCB is also involved with the UNESCO towards developing policy to ensure sustainable development at the global level and specifically in the Asian region. RCB is a young institute which is growing day by day with excellent opportunities for young people to make a career in the area of biotechnology.
Hello everyone, my name is Prashant Pawar. I am assistant professor at RCB. I hope you have enjoyed RCB video, and there are some questions from the YouTube link which I would like to address. So it is regarding the MSc PhD program. So we have MSc PhD program, and the eligibility criteria for that is one needs to have MSc or MTech. For MSc PhD program, one needs to have a BSc qualification in any branch of science, engineering, or medicine. Apart from that, the student needs to qualify JJ bills. Based on the performance in the JJ bills, we will select the students and interview them, and then after that, they will be admitted here. With this, if there are no more comments, then I would like to thank all the students who prepared this video: Harsh, Bharti, Diksha, and Sahil. I would like to thank my faculty colleagues, IIT support, for organizing this event. And most importantly, I would like to thank all the audience. I already see some encouraging comments from the audience. Thank you very much for your appreciation. With this, I would like to conclude this event.